The next part about quadratics that we're going to cover is called the discriminant. It's the part of the quadratic formula that's underneath the radical. So it's the b squared minus 4ac. This allows us to determine the types of roots of the quadratic. You need to pause the video and use the method of the quadratic formula to solve each of the 4 quadratics listed below. We haven't completely simplified these, but using the quadratic formula, this is what you should have for the first one. -3 plus or minus the square root of 25 all over 4. Notice that the part under the radical is a perfect square. In the second one, you got -1 plus or minus the square root of 13 over 6. Notice the part under the radical is the square root of 13. 13 is a non-perfect square. In the third one, 6 plus or minus 0. Again, we got 0 under the square root over 18. And the last one, -3 plus or minus the square root of a negative number over 4. So if we finish doing the quadratic for each of these, in the first one we'd get -3 plus or minus 5 over 4. -3 plus 5 is 2. 2 over 4 is 1/2. -3 minus 5 is -8. -8 divided by 4 is -2. In the second one, it can't be simplified because the square root of 13 cannot be broken down. In the third one, we got 0 under the square root. So we would have 6 plus 0 over 18, which would be 1/3. And 6 minus 0 over 18, which would again be 1/3. And in the last one, this one again cannot be simplified because we have a negative number under the square root, and 23 also cannot be simplified. So if you look at the roots that we've got, for the first one we got -2 and 1/2. For the second one, we've got -1 plus the square root of 13 over 6 and -1 minus the square root of 13 over 6. For the third one, we got 1/3 this twice. And for the last one, we have -3 plus the square root of -23 over 4 and -3 minus the square root of -23 over 4. So we can look at the types of roots that we have, but notice that by looking at just the discriminant, just the part under the square root, we already knew what types of roots we had. We didn't actually have to do the entire quadratic formula. So look at the next page. So for the first one on the previous page, we've got 25 as the discriminant, which is a perfect square. Look at what roots you had. The roots were 1/2 and -2. So if you get a perfect square, you get real, rational, and unequal roots. For the second one, we got the square root of 13. The square root of 13 is irrational, and therefore our roots, our solutions, are irrational. So we get real but irrational roots. And anytime you have irrational roots, they will always be not equal. The third one, we got 0. And what did we get for a solution? 1/3, 1/3. We got the same solution twice. So when the discriminant is 0, we get real, rational, and equal roots. And for the last one, we got -23 under the square root. -23 is not a real number. So we get a non-real answer. and we'll learn more about a negative number under a square root, we call these imaginary numbers. So, we can use the discriminant of the quadratic formula to tell what types of answers we are going to get when solving a quadratic. If the discriminant is a perfect square, we'll get real, rational, and unequal roots. If the discriminant is a non-perfect square, we'll get real and irrational roots. If the discriminant is 0, we'll get real, rational, and equal roots. And finally, if the discriminant is negative, we get imaginary roots. Next page. So we can also use this concept of discriminant to solve a problem or show, like in this example, that it's not possible. So if we have a rectangle and we say the perimeter is going to be 10 and the area is going to be 20. So let's call this x and this y. So that would mean the perimeter is 2x plus 2y and the area is x times y. We can use the formula for the area, 20 equals xy, and solve for y and get 20 divided by x. Divide both sides by x. Then we can use that answer to substitute back in to the perimeter. So for the perimeter we had 10 equals 2x plus 2y. Instead of putting y in, we'll put 20 over x. So pause the video again and see if you can solve this quadratic. So what we would do is multiply through both sides by x. We would get 10x equals 2x squared plus 40. We would then set it equal to 0. Now we can just look at the discriminant. The discriminant is b squared minus 4ac. b squared, negative 10 is b, so we get 100, minus 4 times a, which is 2, times c, which is 40. So we get 100. 4 times 2 is 8. 8 times 40, 320, minus 320. 100 minus 320 is a negative 220. Is it possible to have non-real solutions for the length and the width of a rectangle? Obviously the answer is no, and that is why we can say that it's impossible to draw a rectangle whose area is 20 feet and whose perimeter is 10 feet. So in class we'll look at the discriminant, we'll again talk about how it shows the types of roots, and then we'll also look at it graphically and show how the graph matches the discriminant. See you in class.